Okay, so picking up right where we left off, I have a solution for this. Now, just so you know, there probably is a more concise way of taking the decimals that are generated and having it modify the rotation. Having said that, this is still a fairly introductory video, so we're just going to persist with these and manually come up with the rotations, but just know that if you put enough effort into it, you probably could find a way that directly calculates this rather than having to do this manual. However, having said that, this is often the nature of game development, is that it's iterative in nature. You come up with an iteration of it, and then you come up with a better version of it. You come up with an optimized version of it. So it's okay to use a Band-Aid as long as it scales. And in this case, we don't have to worry about it scaling any further because, again, it's an introductory video. So what we're going to do is to get those diagonals, we're going to simply say if x fire is greater than 0, because it's only 4 combinations. Horizontal is positive, horizontal is negative, combined with vertical is positive or vertical is negative. So this is simply going to say, are they both positive? So if they're both positive, that means you're pressing right on the right analog stick, and you're pressing up on the right analog stick. So in other words, you're pressing to the upper right. So if they're both positive, then we're simply going to overwrite that shot rotation variable and change it to, I believe that should be another 45 degrees, so I believe 135. And now it's really just rinse and repeat. If that's positive and this one is negative, then that means you're pressing right and you're pressing down. So that's the lower right corner. So that'd be minus. So rather than adding 45 to the 90-degree angle, you're minusing 45. So it'd be 45. And then we'll just copy both of these. If x fire is less than 0, and this is greater than 0. So you're doing negative, you're pressing left on the right analog stick, and you're pressing up. So that would be negative. So it'd be actually like, if you wanted to use just positives, then it'd be positive 225, I believe. And then if this is less than 0, and that's less than 0, so you're pressing left and you're pressing down, then it should only be negative 45 degrees. So that one we will do a negative. So is that wrong? 255. It is. I think that should be 225 because it's 180 plus 45. Yeah, I think I just did my math wrong. I think that should just be 225, and that'll solve one of the issues. Because the upper left always looked wrong. There we go. So that one was resolved. Still an issue where you kind of circle around. So if you circle around, sometimes it comes out wrong. Whereas if you let it rest, it's fine. So like, see, the left is correct, and then the left was wrong a few seconds ago when I rotated. So I rotated down briefly, and that one was wrong. So it looks like we probably need to tweak this a little bit, but I'm happy with the way it is because for the most part, we're getting the rotations. So there just seems to be some kind of buffering or caching issue where a value is stored that shouldn't be applied. So I'm thinking what we're going to do is, since this happens in the start, as soon as this is done, we can flush that value out. So I'm thinking that's what we're going to do, is that we can like set the the X fire, the Y fire, and the shot rotation back to 0 at the end of this. That way it's not being stored. But anyways, so that got us very close to where we need to be. Not perfect, but really close. And like I said, in my opinion, good enough to keep going. So a few glitches. Like I said, it looks like it's some kind of issue with a value being cached or stored instead of being purged. But again, that's for optimization. Okay, so now we've got a character who can move around and can fire. So now what we should do is let's go to the bullet. You can do physics or physics 3D. Let's keep it 3D. So sphere collider. And let's just see what the sphere looks like. So I'm going to drag this and put it in, and we're just going to zoom in so you can see there's the circle, the green circle, so that looks acceptable. So we can delete it again. I just wanted to see what the what kind of diameter or radius the collider circle had. So now that it has a collider circle, let's set it to trigger. And it can collide with things. Now we need to give it something to collide with. So we're going to start instantiating enemies. Now, I did another tutorial that was similar to this where we just put in the ghost. So I'm going to start with actually the more complicated one this time. So game object, create empty, add component, rendering, sprite renderer. Just so we have something to look at, we're going to put that sprite right there. Oops, got to move it forward a bit. Okay, so that is probably slightly too big. So again, kind of arbitrary. We'll make that 0.9, 0.9. And actually it looks smaller because it's really in front of her instead of being even. Yeah, that's about right. Don't want them to be too big, too easy to hit. So now that also needs a physics, and we got to keep consistency. So the other one had an orb, or a sphere rather, so this will also have a sphere collider. We can see that's too big. So let's edit this, shrink it down. Okay, so what we're going to do now is we're going to give this an animation. Actually, let's also set it to be a trigger. We'll call this slime. I know, very original. And we're going to add an animation. If you don't have this tab, just right click and choose add tab. Now this is nice because Unity 4 didn't do this. With Unity 5, if you have an object highlighted and you click on animation, it tells you the name of the object that you're about to animate. And we'll call this, we'll just call this slime, because it's not going to have separate attacking or idle animations. It's just going to be constantly in motion. And what you do is just click, grab all the images, drag and drop them. You can zoom in a little bit so it's easier to see. Frame rate is way too high. Let's make this 14. If you want certain frames to be held longer than others, the very easy way to do that is just to repeat frames. So like the first frame, I want to be held a little bit extra. So actually, let's do it this way. I should have just moved this out. So you can just grab that like little diamond and move it out. All right, so this, I believe, is the one that I duplicated. Yep, 0, 0, 0, 0, 0, 0, because I'm just looking over here at the sprite renderer. So I wanted this one held a couple extra frames, and then we want the 1. So 0, 0, 0, 1, 2, 3, 4, 5, 6. Perfect. Now, zoom back out. We'll also hold 6 in extra frame. And then we just cycle back. Okay. So now, whenever an object has an animation, it overrides the sprite. So you're going to see this in motion. So basically, it's kind of like as if it's like reaching out. So this is going to be moving around. So what we're going to do is we're going to take that, going to drag and drop it into the asset area, turning it into a prefab. So delete it. And so it's going to need its own controls. So what's going to happen is it's going to be instantiated. And when it gets instantiated, it's going to be instantiated off the side of the screen in random places. So that's the first thing. It gets instantiated. Then it's going to have to be given a motion path, so again, velocity, to chase after the player. So again, we're talking velocity. So again, we need physics, rigid body, no gravity. Now, the instantiation of this object really isn't related with any of the other objects. So this is when you create a GM object. So create empty GM, short for Game Master. There's nothing magical about calling it GM. It's just for you, the designer, to know that that's what you're going to do with this. So right click, create C# GM. And eventually the GM will probably be used for keeping score and things like that too, handling the UI, the user interface. So now we double click on that. And we need to make it aware. Make the GM object aware of the slime prefab. So public transform. And we'll just call it mob. We'll call it mob slime. Save it. We're highlighting the GM object. There it is. Just like we did with the bullet and the Shinigami, you're going to drag and drop the slime onto that variable. Now the GM object is aware of the slime prefab and can now instantiate it. So what we're going to do is in the update section, we're going to keep randomizing where it's going to appear. So that means we need a randomized number. So public int, and we'll call it spawn LOC for location, because it's not in an actual position as far as XY coordinate. We're just going to spawn like 1, 2, 3, 4, and 1 would be north, 2 would be east, 3 would be west, whatever. Okay, so spawn lock equals random dot range 1, 5. Now, according to this, it's saying that the bottom and the max number are inclusive. I've never once seen this max number actually be included, which means that if you have a choice of 1 through 4, then to get that number 4, you have to go up to number 5, because the number 5 will never be instantiated. So if it's 1 to 4, the 4 would never be not instantiated, would never be selected. I don't know if it's a documentation issue or a glitch, but that top number, even though they say it's inclusive, I've never seen it be. And then we're just going to instantiate mob slime. So what's being instantiated? where it's being instantiated. So that's based on the spawn location. So let's just choose new vector 3. And for now, we'll say like -4, comma, let's see, 0, comma, and it's like -3. This isn't permanent. This is just for demonstrative purposes. So if spawn lock equals 1, then spawn there. Oops, sorry, I messed up. I didn't do the third argument. I did what was being instantiated, where it's being instantiated, and then the rotation, we're going to use the object's own rotation. So dot rotation. Sorry about that, got ahead of myself. All right, so now, so if this equals 1, it gets instantiated there. If it equals 2, it'll be instantiated at +4, so the opposite side. If 3 is the random number, then it will be at 0 horizontal, but like +6 vertical. And if it's greater than 3, and that covers your bases just in case 5 ever does come up. So if it's greater than 3, then it would be -6. And what's going to happen is it's going to have all 4 locations filled up almost instantly. But at least you'll see that it's instantiating in 4 places. And every one of these is missing an extra equal sign. So it is, and let's go to window, and let's go to scene. And if you zoom out, you can see there's also 1 up and 1 down. Okay, so, and you can see there's like a gazillion of them getting instantiated. So they're being instantiated based on the location. Now you would need to slow it down. So first, the 4 is not far enough out, so we'll make that -5. Make that +5. And then the second thing we need to do is we need to have a timer. So we're going to do it very similar. We're going to have public int spawn delay and what we're going to do is once it spawns, we set that delay to 1. So spawn delay equals 1. And now we have to add the check in here. So, and spawn delay equals 0. Okay. Now, similarly, we need to create the IE numerator timer. So IE numerator and we'll call it spawn reset. So similar as the other one, yield, return, new, wait 4 seconds. Let's actually give it like a 3-second delay. We don't want too many enemies on the screen. And actually, we're going to modify this just so you can see them getting spawned. Let's bring it down to 4 and -4. So this gets reset. Excuse me, it waits 3 seconds. The delay gets reset back to 0. That way, these will become true again. And now the last thing that we need is that we need this to actually be activated. So, so start coroutine parenthesis spawn reset parenthesis. And that should make the spawning complete. Now again, that's just the spawning, that's not them chasing after you. I think I'll save that for the next video. So now we'll run it. And every 3 seconds, a new enemy should spawn. Here's that one. That one. The ones north and south might still be too far out to see. So let's go to window, scene, and yeah, there's some down there. And you can actually see there's multiple ones you can see. And now one just appeared up there. So for the actual spawning, we don't want them to appear on the screen, want them to appear off the screen. I just did that for demonstrative purposes. So now we can bump these back to like -6, +6, +6, -6, and oh, actually, this should be a 0. For now, they're just going to spawn in those 4 locations. So that's it. We now have a spawning enemy. And it's an animated enemy, so the next video will be moving it around.